Hello everyone, today we are going to introduce a new conception that is called polynomials. First, algebraic expression can be classified in a variety of ways for more efficient study. So today we are going to start with the important class of expression that is called polynomials. Let's give you several examples of polynomials. Here we have 2x squared minus 5x plus 8. And we can also have 2x minus 1 or single x or single 5. They are all polynomials, and if we want to have more difficult one, we can also construct one that is x squared minus 1 over 3 times x times y plus 2x squared y plus squared 2 times times y squared plus y cubed. And in contrast, we also have some examples of non-polynomials. They can be like 3x minus 1 over 2x squared plus 3x minus 5. And it can also be like 2 to the x power, or more difficult, like x cubed minus 2 squared x over y plus 3 times y to the fourth power, or like 1 over x to the fourth power. Now, let's figure it out. What do all the polynomials above have in common that is not shared by non-polynomials? Try to remember that polynomials are constructed by either adding or subtracting terms of the form, like, let's have some more space here, like a times x to the nth power, or b times x to the nth power times y to the nth power. And here we should have some definition about a, b, and m and n. In this case, a and b are both real numbers, and they are also coefficient here. And the m and n are both natural number exponents. Now let's try to find the main difference between the polynomials and the non-polynomials. We can go back to these examples of the non-polynomials. You can see that a variable that cannot appear in a denominator or appear as an exponent or within a radical sign. So that's the main difference between the polynomials and the non-polynomials. Next, let's move on to something about the identification of certain types of polynomials. There is one important conception that we have to talk about is is called the degree of term. The degree of term in a polynomial is the power of the variable present in the form like 3 times x to the fifth power. In this case, the degree of this polynomial is equal to 5. And another one like x to the fourth power, the degree of the term is the 4. So if we have more than one variable that is presented as a factor, then the sum of the powers of the variables in the term is called the degree of the term. Then we show you some examples. If the polynomial is like 3 times x squared times y cubed, that is, we need to calculate the sum of the powers of the variable x squared and y cubed. So the degree equals to 2 plus 3, that is 5. And similarly, if we have the example like 4 times x to the 7th power minus 5 times x squared. So what's the degree of the term in this case? That is 7. In order to get this result, we have to introduce a new principle in this degree of term. That is, the degree of polynomial is the degree of the term which have the highest degree among the variables in it. So in this case, the highest degree of the term is 7. So that is also the degree of term in whole polynomials. So what if we have a constant? What's the degree of a constant? We can have the 5. And by the rules, the degree of a non-zero constant is defined to be 0. Then let's move on to the next part. There is also a rule that is decided to define different types of the polynomials. If we have one variable in the polynomials, that is called monomial. The example is like we have a single 8 and its degree is just like what we just said, 0. So we can call it monomial degree 0. And if we have 3 times x to the 4th power times y squared, the degree is 6. So we can call that monomial degree 6. And if we have 2 variables in the polynomials, that can be called binomial. The examples like 2x minus 3y. That is called binomial degree 1. And what if we have 3 variables together? That is called trinomial. For example, 3 times x squared minus 2x plus 1. That is called trinomial degree with 2.